Hi friends, in my previous video, I have already explained what is overloading and how it works in Java. In this video, I am going to explain some rules in overloading. Let's see the first, automatic promotion in overloading. In method overloading, if Java can't find exact match for a method parameter, it doesn't give up, it levels up. The argument gets automatically promoted to the next higher data type, ensuring the method still gets called smoothly. So let's see how these are promoted. If we call a method with a parameter of byte type, it doesn't find exact method signature with of byte type. It is automatically promoted to short type. It checks for the method which takes the short type as an argument, and if it finds, it go with that particular method, or if it doesn't find, it again promoted to int type and then long, then float, then double. So if we pass the argument with the byte type, if it doesn't find the byte, it checks with short, int, long, float, double. If it finds any one of these in ascending order, it goes with that particular method. So, or if we pass a char type for the argument as an argument to the method, if it doesn't find a char type, it automatically promoted to int type. It checks for the method with int type. If it finds, it executes that particular method. If it doesn't find, it checks for the long type. That is how these are promoted. So this is the example, and I'm going to explain this particular example in my VS Code. So let's create a Java file, main.java, and in this file, we'll take some overloaded methods. Here I'm taking a show method, and I'm printing this int type argument, integer argument, and I'm taking another method which is overloaded, and we'll take double as an argument or parameter and print double out. And now I'll take the main method, public static void main, and we'll create a main object. And now I'm calling m.show of 10. So when I call m.show of 10, the output is integer r. You all know that. So if I compile and run the code, if I compile the code, it compiles fine. And if I run the code, output is integer r. And if I call the method with double type, it goes with the second method as a double parameter and it prints double arg. So again, if I compile the code, it compiles fine, and if I run the code, it prints integer arg and double arg. So if I call with character A, so here I'm calling show method and inputting a parameter as character. So char type, and we doesn't find exact method signature m.show of char. Here we have show of int type, show of double type, but we doesn't find show of char type. So it automatically promoted to higher data type. So after char we have int type. So it promoted to the int type. So we find the same method which is taking the parameter as int. So here this method calls the show of int type method. So the output is integer arg. So the third method call prints integer arg as output. Let's compile the code. It should compile fine. And if I run the code, our output is first m.show method of int type prints integer arg, and second method of double type print double arg, and third method which takes the char, it automatically promoted to the higher type and prints integer arg. So the output is integer arg, double arg, and again integer arg. This is how lower type data type is being promoted to the higher type data type. in method overloading. So this is how automatic promotion in method overloading works. And let's see the second point. In second point, the child always wins in overloading. So we know that we have child-parent relationships. We have already seen in my inheritance video how the child works, how the child and parent is being related. So when Java resolves overloaded method, it always gives VIP access to the child type argument over the parent type argument. If both are present, the child always wins. Here, I am taking string argument and object argument. So we all know that object is a parent class and string is a child class. Here, object and string have parent and child relationship. So whenever I pass the argument as a string, here Pawan is a string. So we call it as object also. So whenever I'm passing a string type, it directly calls the string type method. But if it doesn't find the string type, that is, if it is doesn't find the child type, it goes with the parent. It prints the object method call. So let's see this example in VS Code. And here we change the parameter. First parameter is a string type, and second parameter is a object type. Object is an object class. That is, object class is a parent class of string. And here, if I pass m dot show of Pawan, it is a string. So here it finds direct method with the argument of string. So here we know that string is a child class and parent is a, that is, object is a parent class. So I'm passing string. So it directly finds the string type. So it goes with the string arg. If we compile and run the code, if we compile the code, it compiles fine. And if we run the code, it prints string arg. And here, both the methods are present, that is, child argument is present and parent argument is present. If both are present, it goes with the child only. Child always wins. But if there is only parent type, that is, parent argument is only present. Here I am passing a string type, and for a string, the parent is object. So here it doesn't find any string, so it goes with the object. So if we compile and run the code, it doesn't raise any error. It goes with the parent type. The output is object up. If both are present, it gives the preference to child type only. If the child is absent, it goes with the parent. So this is how the child always wins in overloading. And let's see the third point, overloading ambiguity. There are some ambiguity cases in overloading. Just see that. In Java, both string and string buffer are subclasses of object. When null is passed as an argument, here null is the default value of both string and string buffer. So when null is passed an argument, Java tries to resolve the method call based on the closest match. It checks for the closest match. But here, string and string buffer do not have a parent-child relationship. They are not parent and child. They are siblings under the object. Here, object is the parent, and these two are siblings under the object. These two doesn't have any parent and child relationship. Since both are equal distant from object, the compiler cannot decide which method to call, leading to an ambiguity error. So let's see this in detail in VS Code with an example. Here I'm taking the both overloaded methods. With first method is of string type and second method is string buffer type. string buffer sd. Yeah, and if I pass the if I pass the string type as an argument, it goes with the first method. That is, if we compile and run the code, it goes with the string call. And if I go with the string buffer, and if we call the show method with string buffer, it goes with the string buffer r. So if I again compile the code, java main.java, it compiles fine. And if we run the code, java main, the output is string r and string buffer r. And now if I pass null as an argument, null is a default value for both string and string buffer. If I call null as an argument, when I pass null as an argument, it checks for its parent or anything. So the parent object is not present, and null is exact match for string and exact match for string buffer. So for these two, the default value is null only. So it finds two methods with a exact match. So it goes with the ambiguous error. So let's see, if we compile the code, java main.java, it raises an ambiguous error. References to show is ambiguous because here null is the value of string and null is also the value of string buffer. Both the default value is null. So both method show of string in main and method show of string buffer in main matches. So it raises an error. So this is how ambiguous errors occurs in method overloading. And we have already seen this example. So let's go for the fourth point. In overloading, method resolution is always based on reference type. Whenever we are creating an object, here we create an object like this, parent p is equals to new parent. This is the object creation for parent. So here, whenever we are creating an object, this left side part is called reference type and the right side part is called object, object type. So here the reference P is holding the new parent object. This is the reference type and this is the object type, or this is compiler based. That is, left side part is compiler based and right side part is runtime based. So in overloading, method resolution always takes care by compiler based on reference type. So in method overloading, it is always based on reference type, not the object type. So let's see with an example. I have taken a class with a one class as a parent class and another class which is extends the parent and its name is child class. Here I am taking two classes and I am taking the overloaded methods. First one is void display, which is taking an argument as parent, and void display second method is taking an argument as child. So whenever we are creating the parent object and passing object or display of parent, that is parent reference P. Whenever we call parent reference, it calls the display of parent. And if we call the if we create a child object, child C is equal to new child. So the here reference is child. So if we call the display method with C, that is child, it calls display of child. But whenever we create the object with parent reference and child object, here parent reference P2 is holding the child object and If we pass p2 as an argument to display, that is here for display method, I'm passing p2 as an argument. So here the p2 reference type is parent and object is child. So in method overloading is always purely based on reference type. So it should call display of parent only. It should not call display of child because method overloading is based on purely based on reference type only. So whenever we call object dot display of p2, it just calls display of parent. Let's see this example in VS Code. So here just remove the arguments and let's remove this code and we'll take the parent class and child class. Class parent as first we'll take the first class as parent and we'll take the child class which extends parent. And in main class we are taking two overloaded methods. First method which is taking parent reference and second method which is taking child object. That is first method taking parent object and second method taking child. So here parent, here child, and here for show method we have to pass parent object or child object. So let's create a parent object. Parent p is equals to new parent and let's pass the parent object. So here I am passing m dot show of p, that is parent reference, which is holding parent object. This is the reference, this is the object. And here parent reference is holding the parent object. So when I am calling m dot show of p, it should go with the first method and prints parent of. Let's clear the console and let's compile the code. It should compile fine. And if we run the code, it should print parent of. And if we create the object for child class, here I'm creating the object for child class. Child c is equals to new child. And for show method, I'm passing child c. Here I'm passing the child c. Here the reference is child and holding the object child object only. So m dot show of c. So it goes with the second object because it directly finds child C and the output is child R. So if I again compile and run the code, java main.java, it compiles fine. And if I run the code, it should print parent again child R. And just comment these two. Now I am creating an object whose reference is parent and holding the child object. Here, the reference is parent. Parent is holding the child object. So now I call the show method with P. Here we may confuse that whether it goes with the first method or second method call. It goes with the parent P or child C. I'm clearly saying that method overloading is based on purely based on reference type. So here reference is parent. So this method is goes with the parent p only. So it goes with the first method and it prints the parent arg as an output. Okay, let's save the code. And if we compile the code, it should compile fine. And if we run the code, it should print parent arg. It goes with the parent arg only. So here parent reference is holding the child object. And here you may You may get doubt that why why not child reference is holding the parent. It is not correct. A child cannot hold the parent. Only parent can hold. Cannot convert from parent to child. This is the invalid syntax. So we cannot create like this. We cannot create an object like this. So child reference cannot hold the parent object, but parent reference can hold the child object. So this syntax is invalid. So we can't do like this. So from this, we can clearly say that overloading is purely based on reference type only. So it goes with the reference only. So we have completed all four rules. Thank you. Please like, share and subscribe for more videos.